Okay, let's get started. First, welcome to SAD Community Hangout. So I want to talk about our agendas today. First, I will talk about SAD development status update for the last few weeks, and then Goho will give a brief introduction about like our watching mechanism improvement in SAD v3, and then I will give a demo about our v3Ds features, and then Anthony is going to give a demo about our new lock and barrier features with like v3 API. And then Hatoshi will talk about the OS issues he is working on.
Okay.
So for SAD development status update, so for the last few weeks, we have been actively maintaining SAD v2 features. Basically, we put SAD v2 into maintenance mode. So we have been fixing a few issues around DNS ISR discovery and also SAD CTL tools. And we did 2 patch releases on 2.2 branch. And we also plan to do a 2.3 alpha release maybe this week or next week. And also, we are actively developing v3 features. So we finished the incremental snapshot features in v3. So v3 can handle millions of keys with minimal resource usage. So it will now like take the full snapshot every time it needs to compact the log. And also, we finished the watch features. Goho will do a quick demo later on. And also, we finished the basic features of our leasing mechanism. I will do a quick demo. So that's all I have for the development status update. I think next, Goho will give us a demo on the watch features improvement. I cannot hear you.
Can you hear me?
Yes.
Okay, I will talk. Sorry.
It's better now? It's not muted.
Oh.
I think it's fine now.
Okay. Okay, can you guys hear me?
May I hear you?
You guys hear me? Yeah. Okay, I will talk about like SCD Watch API, focusing on v3 API we've been working on. So what is Watch API? So you want to use Watch API, or you want to watch a key for its change. So like when you launch a like watch command, like watch like plus key, so the watch API is gonna wait until the key change. And then let's say you put the key A and the value B, and then you put like after that you put like AC, and then the watch API is gonna notify you when there's a change in key. So when the key A becomes like C in its value, so watch API is gonna notify you like with the event key A and value C. So I want to give brief overview about like V2 and the V3. So we have like V2, like V2 also has like watch API, and then V3 also has watch API. But there's a like big difference. So V2 uses like HTTP1 and with JSON RPC. And then V3 uses like HTTP2 with gRPC. And then V2, you can only watch like one key per one like TCP connection. But V3, you can watch like more than one keys, like for like one TCP connections. And then V3 has like cancellation. You can like cancel like watch operation like by its like watch ID. And then you can also receive like multiple like watch event. like V2 you can only receive like one event per like one watch operation. I will go over the like details like in later slide. And then V2 there is a hierarchy, like you can have like directory and a subdirectory in V2 API. And then V2 you can like, so V2 like has like recursive watch command, but like V3 like we wanted to make it simple. So there is no hierarchy in V3, but like you can like watch by prefix. So like we believe like V3 is like better, like because it is more like scalable, and then like with like better performance. So we decided to use like gRPC to do that. So gRPC is RPC framework from Google. It is based on HTTP2. So HTTP2 it can like multiplex like multiple like requests into like single TCP connections, like which means like you're gonna need like less TCP connections, which means like less contentions. And then gRPC is also uses like protocol buffer. So it's like compared to JSON, like it is like much like faster to encode and decode. So like you can go to grpc.io for more information. So I did some like benchmark, like V2 versus V3. So if you look at the graph, red one is the V3 or V2, and then blue line is like V3. And then I want to point out launch or like watchers. But like for V2, like so let's say you want to launch like 20K like watchers, that means like you need to like launch like 20K TCP connection. So you need like as many TCP connections as the number of like watchers. So like and then if you look at the latency, like you can see the like same trend. So like V2 has like higher latency, and then V3 is like a much lower latency, like which means like you can like scale like way more. So yeah, like V3 like watch API is like still in like active development. Like we want to make it more like efficient and then more like robust with adding more tasks. And then right now you can like we only support like watch by key and then watch by prefix, but we also planning to add like other like API, like watch by range. And yeah, that's all I got for today.
Thank you for the introduction.
Anthony?
Wait. There are some people in the Google Hangout.
Okay.
Yeah, I told them to jump over here.
Okay.
I made the same mistake. Let's see.
Do any of us have one? Go ahead.
Wait, I think you're sharing. It's telling me I can't share.
Which one? I get that one. Stop share.
Oh, all right.
Okay, next I'm going to talk about the least features. So I will give a brief demo.
None of us can hear Xiang. Does anyone have their microphone?
I could hear Sean.
My speaker's on. Can anyone hear me aside from you guys?
Yeah.
Am I audible? Can you guys hear me?
Michelle says everything.
All right. You guys see the slides? They showing up?
Yeah.
Yeah.
All right, sweet. Okay. So I've been doing some work with trying to vet the V3 API to see if it can support common synchronization primitives. Mostly this is a reimplementation of Zookeeper recipes, but there's a little bit more too. So the recipes that I've implemented are barriers, queues, locks, also software transactional memory, and elections are kind of in progress. So the V3 APIs, split this into reading and modification. So to read data from using V3, you can do a range request to get a range of keys. It's paginated, so you don't have to load all the keys at once, which is important for efficiency. You can also do sorts by key value modification, revision and creation revision, as well as decide on the whether the order is ascending or descending. So this is important for queues and locks, as you'll see. Also, it supports watchers. So this, as Gyo just mentioned, so it lets you monitor event information on keys like puts, modifies, and deletes. The modification part lets you put key value pairs like V2. It also supports leases, which are a replacement for TTLs. So leases are useful for basically revoking keys all at once. There's also delete range for doing bulk deletes, and there are transactions, which are important for synchronization. So transactions are ordered so that you can have a list of conditions, and if the conditions are all satisfied, then a success list of statements is applied, and if not, a failure statement list is applied. So to build some primitives, you first need some special keys. These are all built from the V3 API. If you're familiar with Zookeeper, these will be familiar. So I added support for unique names, so you can create a key with a unique name in the key space. There's also support for ephemeral keys, which are keys that are attached to the lifetime of a process. So this means that if like your client crashes, the key will eventually go away. And there's also sequential naming if you need sorted names with a sequence. Sequential keys are actually sort of tough to implement, and they're a little pricey. So I suggest using unique keys. But the main idea is that you can do a range request efficiently, sort by key name, and then do some transaction magic to get the new name for the key. There's heavy contention on that first node because it's doing the update based on modification number. So it's not suggested to use this if you think it's going to be updated a bunch. So first primitive barriers, this is very simple. You can create a barrier and hold it, and then any process that tries to acquire it will wait. So this is just creating a key, and then when you delete it, everything is free to move forward. Double barriers are a bit more complicated. This is when you have a number of processes and you want to gate them, and then once all the processes arrive, they're released, and then all the processes then do a leave, and then they're released again. This synchronization is a bit more tricky because there's some dependencies on to avoid thundering herd issues. So instead of doing a full broadcast, it listens on different nodes. This is mentioned in the Zookeeper recipes document if you're interested in the full algorithm. It also uses ephemeral key, so this is important. So like if you have a crashing node, you don't want your barrier to be stuck forever. So because you have ephemeral key, when the node crashes, the lease will be revoked, and you'll be able to make forward progress. So there's also support for queues. Main idea here is you just create a new unique name, and then you can list by modification number to get the newest one. There's heavy contention on the head node, so keep that in mind. Priority queues are similar, except they use sequential names in order to be able to sort based on priority. I'm just skipping through all the details because it's kind of boring. The code will eventually be released. It's almost ready for a PR. And finally, locks. So lock implementation is kind of smart in that it only waits on the prior waiter. So this avoids thundering herd. So if everyone were to wait on acquiring a lock, then all the nodes would try to grab it at once. And this is smarter in that it just waits on the last node to acquire. So this is the status. Most things are working. Some stuff's in testing. And there's a demo if anyone's interested in trying this. This is my machine at home, so don't be mean to it. So if anyone wants to try logging on to this queue thing, the queue thing's more interesting. So I've got an STM demo. I'm not going to switch screens because it's kind of a pain, but so the idea here is you can use software transactional memory to do the classic banker algorithm where you're trying to exchange transaction amounts between different balances. And so this is a kind of an example of that. You'll see that all the balances add up to 100 times the number of line items. Second, I have a demo with queues. So this is basically you can request queue data through your browser, and if there's nothing on the queue, it'll wait forever until you put something new on it. So questions? Anything? Kind of zoom through it.
For the ordered keys,
Yeah.
Is that's implemented on top of the V3 API?
Yeah, this is all on top of V3 API.
I see.
Yeah.
Okay. And so all the ordering essentially is a get and then update. That's why the contention.
Yeah, well, you have a transaction on this one node, and
Right.
you basically want to make sure there's been no updates since.
Right.
And that, yeah, so that's why you want to. Usually, you can get away with using unique keys, and then you can just sort on modification number, and then you don't have any contention
I see.
or very low contention.
I see.
Yeah.
Okay.
Great.
And then I guess the last question: have we gotten the ephemeral keys implemented in
Leases are still in progress.
Okay. Okay.
Probably by the end of this week.
Okay.
Like it's we don't have forwarding yet, so you can only talk to the leader leases.
Got it. Okay.
But we'll probably find bugs.
Cool. Thank you.
Yep.
Okay, can you hear me?
Yeah.
So I'm going to give a demo of our lease feature. So it's working in progress, but like we got some progress, so I want to show some progress here. So. Well, I'm not sure how I share a screen. Okay, so I started ICD v3 on my first terminal, and so I'm going to give a demo on the lease features. So the lease feature, so you can create a lease and you can attach keys to that lease. If that lease is revoked, if that key of the lease, if the lease is revoked, all the key attached to that lease will be deleted. And if the lease itself is expiring, all the keys of that lease will also be deleted. So I'm going to give a demo. So first, I'm trying to like create a lease by using ICCTL stuff. So I'm giving it a very long TTL in case this lease will be expired. So I create a lease here. So on this terminal, I can create keys attached to that lease. So each lease will have its own lease ID. So here I create a key with this lease ID, and then I can create another key with the same lease. And then if I do a range query, I can see both of the keys. So at this terminal, I'm trying to revoke the lease. What I should see is all the keys attached to that lease should be deleted. So if we do the run query again, all the keys are deleted. So another thing I want to demo is the lease expiration and also the lease keep alive. So we create another lease with a shorter TTL, maybe 10 seconds. So the lease will be expired by after 10 seconds, but what I'm trying to do here is try to keep alive this lease, so it won't be this already. I need to create another one and do it faster. So in this terminal is try to keep alive this list, and then I can try to put keys on this newly created list. So this terminal is trying to like doing keep alive for that list. So I can see the key still here. If I kill this terminal, so no one is going to like keep alive this list, and after 10 seconds, this list will be expiring, and the keys attached to that list will be deleted. So we wait for a moment. Now the key is deleted because the list itself is expired. So this is all I have for the demo. So I think we have the last item.
Hey, Xiang.
Hi.
Who's in charge of actual expiration of the leases? Is it the current leader?
Yeah, the current leader is in charge of the lease management.
I see. And then the leader will be the one who submits the deletion to the graph log. Okay.
Yeah.
Okay, thank you.
So if there is a leader election, the new leader will take in charge of the lease management, and it will refresh all the leases, the TTL of all the leases, but we haven't implemented that part, and it will be implemented maybe this week or next week. Hi, Hatoshi, I think you want to talk about the
Yes. I don't have a slide today. I just want to check the status of the authentication mechanism. Currently, it seems that the authentication mechanism is broken in the etcd server. So I think it is a little bit dangerous. So fixing it would be required. In the issue I linked in the Google Docs, Sean said there are some issues related to authentication mechanisms. I have a question about these issues. What should I do? What should we do for recovering the authentication mechanism?
So I think the issue you mentioned is caused by the caching, because like in the auth stuff, we have a cache about like if the auth is enabled or is not enabled, and the authentication is now operate at the API layer. So when the actual route log get committed in the server side, it will not propagate to the API layer again. So like it works perfectly on the leader side, but it doesn't work well on the follower side. So I think in your pull request, you add a hook from the API layer to the server layer. I don't think that is a good idea, because so we don't want like the API layer directly talk back to the like as a server layer. So I think a better solution is to like move the auth stuff back to the server layer. So the server will in charge of the authentication mechanism, rather than let the like API layer in charge of the authentication mechanism.
Okay. Okay, I see. So migrating entire authentication mechanism would be required.
Yeah.
Okay, I see.
Also, I plan to fix that, but like if you have time, you can do it too. Like just move the authentication part like from the API into the server. Then like when you commit the route log, you know, okay, this is a route log that modifying the authentication part, and then you can disable or enable the cache again.
Okay, I see.
Adding the hook stuff.
I see. Thank you.
So any other questions or any other issue we want to discuss?
I have one. Listen, when you said about the leases and that I can delete all the keys and values in the lease, how does that differ from that I have a namespace that prefix in the key? Because from the user perspective, I see that I can group my key values in a list, or I can group them in the namespace. And now I have the problem that I can manage the key values in another dimension, I can say.
Yeah.
But for example, if you create a API that you allow to list all the key values, so I can ask for the key values from the list or from the upper namespace, right? So
yeah, I think you can group your key by namespace, and like for now, list only support like lists on keys, but like in the future we can like support lists on the namespace too. Like you can create a list on namespace. If that list is deleted, all the like keys under that namespace is also deleted. And the main like issue is that we want like separate the TTL from the key space itself to another like entity called list, so you can attach stuff to the list, and list can transfer from one machine to another machine by list ID.
okay.
And like another thing is like when you update the TTL of the list, you will not get the like update notification of a key. So in ICD v2, like when you update the TTL is actually an attribute of a key, so you will observe that the key itself is changed. But like in most cases, people don't want to see like the TTL updates on notification of a key.
Okay, that's answer my questions. But, I have a little doubt that okay, I could just use the. It can be a little complicated that manage all the keys in the all leases, right? Again, because now you're creating two dimensions, so one is namespace and another is leases, and I don't know. It's okay. I have just this doubt. I guess I have to process what you said, maybe.
Yeah. Maybe you can give the API a try, and if you have any like questions or you want us to make it simpler, we can do it too.
Okay, thanks.
Any other question? No. So we plan to like do this like community hangout regularly. Maybe we will do it after 2 weeks or 3 weeks. So we'll send out new updates on the community hangout thing, and see you after several weeks. Bye.
Bye.